All right, we're going to go ahead and get started. We have Kelly Yates here today. She is the Collaboration and Program Development Manager at Utah STEM Action Center, and she has some amazing information to share with you.
Well, hello, everyone. I'm so happy to see you. Um, I hope you've had a good day. Your sessions look fantastic. I hope they've been beneficial, and I hope that this one just kind of adds to what you've already been learning and developing today. So, to just explain a little bit, the STEM Action Center is a government agency. So, we were created to help teachers and educators and parents um, better prepare students for STEM in the future. And when we talk about STEM, I want to know, what do you think that is? Or what is it to you? So, what I'm going to do is I'm going to share a link in the chat box. And I'm also going to share my screen. And I just want us to have a quick kind of sharing of ideas. What is STEM? So when you click on that link, you're going to see a page that looks like this. This is the Jamboard. It's where we can share our ideas. And if you haven't used a Jamboard before, over here on the left, you have this bar of tools, and there's one that looks like a sticky note that's under the big arrow with a circle around it. So if you click on that, then you can just type your answer and then push save. And you can, change your color, be wild, enjoy the experience. So let's just get some answers up here. What is STEM? How do you explain it? What do you think of when you hear it? Excellent. And I'm just going to start dragging some of them around so they don't all pile up on each other. Yeah, excellent. And I'm going to give you about 30 seconds more. All right, if you're writing one right now, go ahead and finish up. And then we'll come on back to this. Excellent. Okay, I love what you have to say. We have some strong foundations to build on. So STEM, I just want to make sure we're all starting from the same page. So STEM has a couple of components. It has a content component. I'm going to kind of clump those together over here. These are like the school subjects that we address with STEM. And then we have the cultural component. So I'm going to put this one here. So we are going to be talking today mostly about these content components. We're talking about science and math specifically today. But I want you, as we talk, to consider or keep in mind all of these cultural components that STEM provides us. And the reason I'm bringing this up is because sometimes we hear STEM is great for that person. I'm an art person, so I don't need STEM, or STEM isn't for me or my child. Well, it may be true that your child isn't going to have a career in science or math or engineering, and that's just fine. It's like we don't need everyone to be an engineer. That would be awful. But we do want a population of individuals of all ages that are engaged in these kinds of cultural activities. We want people engaged in hands-on learning. We want people having hands-on experiences. Exploring the world around you. Like, what artist doesn't do that, right? So all of these cultural components, these pieces, are the bits of STEM that I personally feel are actually more important. And the reason is because these apply to every person, every student, regardless of the career they end up in. We want people that do these things. So as we talk, just kind of remember that. And if you have questions as we go today, don't hesitate to just turn on your mic and ask. That's fine with me. We can also use the chat box. So whatever you're more comfortable with works for me. Like Chelsea said, my name is Kelly Yates. This is me. And this is my email address. If you want to get in touch with me later, I'll show it to you later. If you decide you need it. I want to show you one of my very favorite quotes, and I am going to present so you can see this the way it's meant to be seen. And this is by Leonardo da Vinci. He said, "Learn how to see, realize that everything connects to everything else." This is one of my favorites because I think it underlines all of the things that I feel are important about STEM. And we can take this idea and transfer it anywhere, or to any person or to any setting, and it's appropriate, and it reminds us that our actions have impacts. You know, the things we do have impacts that we don't see initially. And I think that's a beautiful idea. And it's something that we ought to be aware of. And that applies to, again, those cultural components that we develop when we teach STEM. So that being said, we are going to dive right in to talking about some of the standards that have been established for 3 and 4-year-olds. And we're going to focus on math and science, obviously, since we're talking STEM. But what I want to point out is that all of the science standards revolve around these 4 actions, these 4 things. So we're talking about obtaining information, we're talking about patterns, we're talking about collecting data, and planning and carrying out investigations. So keeping those 4 things in mind, we're going to look at each of the 4 science subject or content areas for 3 and 4-year-olds. And the first thing that I want to show you is this picture. And I want to know, what do you think of when you see this picture? Just feel free to write it in the chat. I'm going to give you about 30 seconds, and I know it's a little hard to see. So this is a street of homes in Utah during a rainstorm. What comes to mind? Or what would come to your students' mind? Nice, we've got some responses. Oh, I'm loving your answers. I want to just, in case anyone's not reading the chat, these are fantastic. So we have things like wet, cold and wet, peaceful, the sounds of raindrops falling, playtime. I love that perspective. A wet house, definitely been there. July, basement flooding. Some really great question. What causes rain? How do we measure it? And jumping in puddles. Look at all these puddles, puddles, a lot of water, puddles, puddles. I think my dogs are friends with these people. That's what they think of when they see puddles. Water to drink, April showers, movie day. I love this. Humidity, looking for worms. Yes. Boat races, rain boots, and umbrellas. Oh my gosh, clouds. These are wonderful. So, how could we use this kind of setting either in actuality? How can we use a rainy day, or how can we use a picture of a rainy day to help our students? I love this, plants getting a shower. Oh my word. Um, how do we use this environment, this occurrence? In science, we would say, how can we use this phenomena to communicate information, to describe patterns, to collect data? What do you think? What have you done with your students? What could we try with our students when we get a rainy day like this? What could that look like?
So going off of the what someone said to collect worms, this was for math, but you could measure the worms, see how long they are.
That is an excellent idea. So you could absolutely tie math and science together. We're integrating them, which is always a goal in STEM. We would be collecting data, and we might describe some of the patterns we saw with those worms. That's a fantastic idea. Ooh, teaching the water cycle, rain cloud experiment in a jar. I love how you guys are thinking about this, listening to the rain. This is wonderful. Now I want to show you another picture. It's similar, but it's not the same. So let's take a look at this one, maybe. There we go. How do the questions change? How does the experience change now that that precipitation has become snow? What do you think? I'm going to give you another 30 seconds. Oh, excellent. All right, again, in case someone's not looking at the chat. Cold. I love this question. Is it a good idea to eat snow? I told the last group my husband and I made, when we first got married, we made snow cones out of fresh fallen snow, and we definitely ate them and they were delicious. May not have been our best idea, but we totally did it. Seasons. I love that you pointed out the seasons, because isn't that an excellent way to bring in some natural examples of patterns? Sledding, how deep is the snow? Again, collecting data. Beautiful snow angels, snowmen, snow huts, snowflakes. So many things that we can use this particular setting for. Oh, I love it. Water can be solid, liquid, or gas. Excellent. Christmas, another pattern, right? That our students might be starting to recognize. It gets cold, it gets snowy, and then it's Christmas. Excellent. Hot chocolate. Ooh, I love that. building, snow bin, watercolor, animals in the snow. I love it. These are great, you guys. What I want us to do as we go through these science contents is I just want you to think, how can I use what I'm already doing and just be a little more deliberate or explicit, saying, look, now we're doing science. It doesn't have to be formal. You're already doing STEM. We just want to acknowledge it so our students know that they are scientists. They are mathematicians. Let's recognize the skills that are already in them, naturally, inherently, especially as young people, before they get kind of bogged down. You know, let's build them up. I love it. Okay. So the first science content for this age group was weather. The next one is light. So I've put some pictures up here, and I picked these quite deliberately. So what do you think of when you see these pictures? What is first coming to mind? Shadows, nice. Very good. Bright versus dark, excellent. Heat, nice. The warm sun, reflections, fantastic. So I'll explain why I picked these ones, but you guys have some really good reasons. Oh, food, nice. Absolutely. So light impacts all of those things. So over here, if you're my age, you might remember metal slides, and you would go down wearing shorts and your legs would always feel a little bit burned afterward, or they would feel frozen if you did it in the winter. So I've got a metal slide and a plastic slide. One of the things we want students to understand about light is that light interacts with different materials differently. A related one is represented by this picture. We have some black shirts and we have some white shirts. Why would I have picked, if we're talking about light, why would I have picked black shirts and white shirts? Any ideas?
If you're wearing black, it's going to absorb more heat, so you're going to be hotter and sweat more.
Exactly. So just like materials affect our temperature and how we interact with the light and heat, so does the color. Okay, so maybe you have a black t-shirt and a white t-shirt and you put one on one student, one on another, and go measure some temperatures. How do they feel? You know, that would be a really quick way to have students experience that. Now this picture are some sunflowers, and these ones on the left are growing in the dark, and these ones on the right are growing in the light. What do you observe? Maybe some things to look at are the height. Why would the dark ones be taller? What's happening here? Yeah, so Jenny says those in the dark are taller, but those in the light are healthier. Yeah, the ones in the dark are looking for light. So they grow up tall, but they're really thin and weak. And you can see they only have like a single leaf on them. They don't actually have what it needs to build themselves out more. They can't grow two leaves. They don't have the building blocks to do that. They're just looking for light. Whereas this plant in the light has what it needs and is able to continue growing. Okay, this is something that you could pretty easily set up even in your classroom. You could put these ones in a box. You could put some fabric over them, the dark ones, put these ones in front of your window, and just compare. That would be an excellent way for students to develop their understanding of how light impacts living things. We also have here a blanket fort, because I feel no 3 or 4-year-old should experience life without a quality blanket fort at least once. And you can see that it's kind of dark in there. So they've put a lamp over the top. Well, the science standard associated with this is that light illuminates the things around us. It allows us to see our surroundings. So you could very easily set up situations where it is light and where it is dark. Have them use a flashlight, make a maze and have them go through in the dark and in the light. Things like that so they can experience what it's like and what light does for us. And then over here, we just want them recognizing that when they're in the light, sometimes they feel heat. All right. So those are some kind of ideas around light and how we can introduce our students to it in a way where they could do all of these things. They can obtain information, they can describe patterns, they can collect data, and they can carry out investigations. The next one is all about living things. So wasn't that a good connection? We went from living things need light right here. Talking about living things, I mentioned before in the last group, I have a niece that's 3 years old and she currently has a pet rock, which is fine. Like that's fine, have a pet rock, but she believes it's a living thing and likes to give it food and water. So I am hoping that we can use that as a way to say, is it using the food and water or is it just sitting there? Maybe it's not a living thing if it's not using food and water, because we want our students to understand that living things have basic needs like food, water, sunlight, and air. So that's something that we could create an investigation for, have our students observe. We could grow plants. And just like in that last picture, you know, what happens if we don't give them food? What happens if we don't give them water? What's happening to the health of that living thing? What do we observe? Those sorts of projects and experiences really support the idea of living and non-living things in our youngest learners. One of the standards also is associated with students understanding that oftentimes living things need the support as they are young of their parents to make sure they stay healthy and strong. So this kind of activity where they can match an infant animal to an adult animal is always a good experience. Of course, you could have them maybe draw a picture of themselves and a picture of a parent or other adult who takes care of them so they understand that they're a living thing. Some of these can get tricky, right? When we have a tadpole that turns into a frog or a caterpillar that turns into a butterfly, those are a little tricky, but it also helps us get into the life cycle as they're ready. So some things to think about and help our students explore. We can also talk about here when we have baby animals and parent animals. Well, how are they the same and how are they different? You know, usually baby animals are smaller. Usually they look similar, but not exactly the same. But then we do have kind of those weird examples, you know. You never know what to do with a caterpillar turning into a butterfly, I'll be honest. But it's also a great experience for students to watch. So these are some ideas about how we can introduce students to the idea of living things and some activities we can engage in to help them kind of internalize that learning. We're going to keep going so I don't run out of time, but the last science one is matter and motion. And matter and motion are two words that are kind of advanced when we're talking about science terms. So what I want you to think about with matter and motion are, as you are already brought up, we have the different phases that an object can be or a material can be. So we have solids and liquids and gas. How do those interact? How do we use them? Which things can switch between one or the other? How do we contain them? Those kinds of things, they can play around with those ideas. We also have sink or float. Those are really important when it comes to density. matter is a hard thing even for older students to understand. So the earlier we can get them to understand that things don't have to look the same to act, or things that look the same can act differently depending on what they're made of. That density idea can be really tricky. So as we get them comfortable with playing with it, that frees up their minds for in the future getting more complicated. So yes, always sink or float. They will always find something that you didn't plan on testing for you to stick in your bucket of water. And that's okay. Like, again, we want to encourage that exploration. So, okay, yeah, let's put your pencil in. Let's put your hair clip in. Let's go for it. Let's see what happens. The more that we can set up our space to allow them to make a bit of a mess, which will happen, absolutely. The more we can encourage our students to really go with their ideas as they happen instead of having to filter what they want to try. So sometimes set up a messy space. I will also tell you, I taught technology and engineering, and I would say for half of this school year, people would come into my classroom and be like, good heavens, what happens in here is a disaster. But it was an organized disaster. And I think that that's where we have to focus. Like, everyone knew where the materials were. It looked like I had piles of garbage around, but they were actually projects being made of recycled materials, so we just have to go with it and understand that creativity can be messy, and that's okay, because how else will they develop the skill? Now, I included these cars here because it reminded me, we had a classroom grant this year that we funded for a preschool to get a good ramp that the kids could push and pull their cars up and down, because that is also an integral force when it comes to matter and motion. Pushing and pulling is really important. Some other ways to model pushing and pulling could be things like marble coasters or dominoes. We want them to understand the difference between those two actions. All right. Do you have any questions about the science things we've talked about? Because we're going to switch to math. All right. I'm not seeing any questions. Yeah, it is an organized disaster. You're exactly right. Yes, I felt like that's how I lived as a teacher for a while.
When doing science projects with them,
Mhm.
and like, let's say there's like some sort of chemical reaction and everything, what if you don't fully know what exactly the chemical reaction is? Do you just simplify it for them, or how does that work when you're describing it to them?
Yeah, that's a really good question. So I would simplify it as appropriate. So simplify it in that it's still correct, but just a more basic level. And if you don't know, this is key to STEM instruction. And I wish every teacher asked me that question so I could say, STEM is a space where we encourage you saying, I don't know, let's find out together. Because you can't know all of the science in the world. You can't. It is not possible. And anyone that thinks that you can or should is not right. So STEM is a safe place to say, I don't know. And then working with your students as they are ready to investigate further is the best way to manage that, because that's what we would want them to do when it was their question and they are in a place where they could manage that themselves. Like, what does happen if I mix water and baking soda, what happens? Nothing. But if I add this other clear liquid, vinegar, to the baking soda, then it all fuzzes up. Like, what's the difference? How is that happening? And they're not going to be able to understand the answer that it's because the pH levels are different and the hydrogen atoms are moving from one material to the other until they become neutral again. Like, that's not going to happen. But you can certainly say something like, it seems to me that these mix in different ways. Something's happening as I mix these materials. that causes them to react differently. And both of these are clear, so it must not have anything to do with the color. We're going to have to investigate further. And then again, as they're ready, you can get into, well, what is vinegar? You know, and they wouldn't be ready for that at 3 or 4. So I would stay with, you know, when those two things mix together, they have a reaction. And a reaction is an excellent science word. And they react because they're different than each other without getting into pH. That's a lot. Yeah. I love beautiful junk. I'm reading the comments. That's a really good question though. Please always feel like you can say, I don't know also. Yeah. Any other science questions right now? Okay, I am going to skip a couple of slides and get to this. And I want you to take a look at these. Oh, you're right. Yeah, take a look at these images. And I want you to decide which one doesn't belong. And put your answer in the chat along with the reason you think that's the answer. So 30 seconds again. All right. Good. So I think you guys are getting the idea. All of these could be the correct answer to the question I asked. And they all have reasons that could make them the correct answer. So let's just take a quick look at them. As you said, it could be the heart, if you picked the heart, because it doesn't have any straight lines, it doesn't have any straight edges. It's all curves. It also could be the star. And it could be the star because it doesn't have that red outline like the rest of them do. Or it could be this green shape because it's actually made of 2 smaller shapes. It's a composite shape, right? It has a triangle and a square. Or it could be this, I think, decagon. Nope, decadogon, because it's not colored in the middle. All of them could potentially be the correct answer. So I want to point out as we start to talk about math that one of the most important things that we want students to understand as they start to explore math is that there is often more than one right answer, and there's almost always more than one way to get that answer. So I liked to do these activities with my students every so often, especially when we were having a hard time working in groups, you know, just to say, why could that person's answer be right? Well, why could that person's answer be right? So what you're saying is every person's answer is right, and they can all justify it. Now, there are, of course, certain things where there is one right answer. But it's important to remember that the way we get to those answers are as varied as the people answering the question. So, delving into mathematics, we are going to keep that in mind. The other thing that I want to just let you all know before we get into this is math is currently seen as a huge barrier to STEM. Most people think that they cannot do STEM because math. And as we dig deeper into the research behind that, we are finding that students' mathematical exposure by age 5 determines, to some extent, to a large extent, their interest and their perceived ability in math. So when we have a 3-year-old that is saying, I don't like math, my heart breaks, because that perception is going to impact them for the rest of their life if there is not a direct intervention provided. And we all know that we don't have enough people right now in education to provide all of those direct interventions. So we need to start out at these earliest ages, encouraging people, encouraging our students, reminding them that they are mathematicians and they are scientists and they are engineers. And wrong answers don't mean that they are not math people. Wrong answers mean that they get to explore the problem more. Okay, I know that that can be frustrating language, but that is the truth of the matter. We also found when we gave a survey to Utahns across the state that parents of early learners, ages 3 and 4, even 2, didn't feel like they had the skills they needed to talk to their kids about math. So as we delve into this, first remember, every person is a mathematician. Second, remember, goodness, never say I'm not a math person in front of your students, even if you feel it to your core, because it will affect them as also. We know that they absorb everything you say, let's be real. So, be cautious about how you share your feelings about math, but also, if you're not a math person, let's see if we can change that. Let's see if we can find a way for you to love math, at least a portion of it, a part of it that you can enjoy. Keeping that in mind, we're going to dive into this. So I'm going to back this up a little bit. And I just want to show you, I've got the math skills. Their standards are framed just a little bit differently. So I've got the skills listed here, as you can see, and I've bolded the ones that apply to this particular content. So in math, the first one that we're focusing on is counting and cardinality. So we do want students to be able to count by ones. And we do want them to understand that as we go along that sequence, we're actually increasing in quantity. And that's kind of what this cardinality means. It's that one-to-one relationship. We also want them to start becoming familiar with the symbols that represent numbers. And by 4 years old, we're hoping that they can tell those apart from the symbols that represent letters. So those are some activities that you could engage in. There are so many of these online. I love this caterpillar one. We actually made a similar one for one of our kits that I'm going to tell you about. But activities like this, where we have the number of objects and then the written number, so they can associate the symbol with the quantity, is really important and pretty adorable. Like, who doesn't want 10 little dinos, right? That's cute. Okay. Next, we have operations and algebraic thinking. And when you see that title, you're like, I don't even know what that is. Not going there. But what it really is about, when we're talking about our youngest learners, we're talking about identifying patterns. We can do this with art projects. We can do this with songs that have a song and a verse, or a chorus. You know what I mean? A verse and a chorus and a verse and a chorus that repeat, that cycle. Okay, we're identifying patterns. We can talk about the seasons and we're identifying patterns. This is an essential skill to be successful in mathematics later on. So those patterns, finding them everywhere, matching socks, let's find patterns. Like, fantastic activity and good for their little motor skills. The other thing we can be doing here are comparing quantities. I have a few on one side and more on the other. identifying which bucket has more objects than the other in it. It's a really important skill. Last, we have addition and subtraction, and this is really up to 5. So we're adding maybe 1 plus 4 or 1 plus 2. Definitely not getting into any double digits or carrying or things like that, okay? Now, the reason I have this picture right here, these are called sum blocks, SUMBLOX. These are actually, were designed in Utah, and they are numbers, as you can see, and the number they represent, the quantity they represent, is also represented in the size of the block. So you can see the 5 block is smaller than the 6 block, which is smaller than the 7 block. These are a great tool. They are now mass produced, and made in a warehouse kind of factory situation. But for a while, they were just making them in Logan by hand. So you can purchase these. And I'm going to tell you about a grant we have to help you make those purchases in a few slides. So these are a wonderful tool. If you don't have them and you're interested in them, I can tell you more about them. Next, we have measurement and data. And what we're talking about here, I put another one of those activities here because this is an excellent way to talk about measurable attributes. For example, I have 3 big dogs and 1 small dog, or I have 3 white dogs and 1 brown dog. We can also sort and classify. This is where that worm activity, measuring our worms that we found in the rainstorm, would fit right in. We could also sort or classify. So maybe we go outside on a walk and we say we can identify different types of bugs based on their color or based on their size. Or based on, did I only see one at a time or did I see them only in groups? So those are all ways that we can sort and classify that are going to capitalize on our students' natural interest. Next, we've got geometry, and there's lots of ways to integrate this. What we're focusing on is shapes, shape recognition. With 3-year-olds, we're focusing on 2-dimensional shapes, those flat shapes. And with 4-year-olds, we're adding in recognizing solids. So things like a cube or a cylinder. We're also talking about spatial relationships. Interestingly, the research tells us that young boys are far better at spatial relationships than young girls. And some of the reasons for that are related to things like playing outside, engaging in athletic activities like soccer that you can do when you're little, and a way to get people more involved. You could try yoga in your classroom. I teach yoga. I love doing it with little kids, and they're fantastic at it. You can have them make different shapes with their bodies, but it also helps them develop the spatial awareness associated with words like in front of, above, below, behind. Those are the kind of words that we want them to be familiar with, and little boys are getting exposed to that in the activities they stereotypically engage in more than our young girls. So an important disparity to recognize. Now I'm going to keep going. I know we're going fast, but I want to show you some resources. So
Ellie,
yes.
Before you start, there was a question that asked what the blocks, those number blocks were called.
Good question. So they are called the sum blocks. It's SUMBLOX, sum blocks. Good question. Thank you for stopping me. So as we look at some of these, I'm going to actually talk about this bottom thing first, since you mentioned the blocks. Sometimes schools don't have a lot of money for materials. We know that. All right. So we have a grant called our classroom grant. It opens in early August every year and closes at the end of September. I can guarantee that it'll always open and close then. Sometimes we open it again later in the school year. And I'll tell you about how to find out about that in just a moment. But this is a grant where you can request up to $1,500, and that can be used for equipment, materials, supplies, consumables, you know, things that you need to do the stuff you want to in your classroom that you may not have access to. I've been over this grant for 6.5 years. I have received 3 applications from preschool classrooms. All 3 of them have been funded. I would love to see more. So I make this offer to everyone. 4 people have taken me up on it. If you don't feel comfortable writing a grant, I oversee this grant, but I do not help review it. And I do that because I feel it's important for me to offer support to teachers that haven't written grants before. It can be scary. You're not taught how to do it typically. So let me help you. If you need help filling out the grant application, if you have a group of you and you want me to come down and work all together and we can each fill out an application for your school, let's get that happening. I'll show you my email address again when we're done, but please, please take advantage of that opportunity. Like I said, we would love to see more. Thank you, Chelsea. We would love to see more preschool applications. Like I mentioned, we did fund a heavier duty ramp for one classroom this year so they could run their cars down and then pull them back up and talk about which one took more force, which one took more energy. You know, those are the kinds of things that we want to support. We have funded some blocks before, which is why they were on my mind when I showed that picture. So please, please let me know if you have questions about the grant. Like I said, it will open early August. It's usually the first Monday in August that it opens. And then it always closes September 31st. It takes me a couple of weeks to get the grants reviewed. So you'll have your award by the end of October if you're funded. We also have a pretty high fund rate, about 70% we're able to support. So good question, Leslie. I'm going to actually show you. So I'm going to just go to our website real quick and I'll show you where to go. So our website is stem.utah.gov. Oh, I spelled it wrong. That's embarrassing because ATEM is not a word. Here we go. So if you go to educators and then come down to grants, you're going to get a list of grants, which is all very well and good, but the one you want to find is the one called the Pre-K to 12 Classroom Grant. Just click on Learn More. Here's the description. It's kind of what I just told you. We want you to try something that you haven't done before. And here's what we can pay for. We cannot pay for things like a teacher computer. So it does need to be used for your students. Here's the timeline. This is from last year, but these same dates would apply for this year. This is where you can see how it's scored. This is where I made a video where you could just watch me showing you all of the sections of the grant and what I'm looking for. And then this is where you would click to apply. So if you click on apply now, thank you so much, Chelsea. If you go to this, then you're going to have to, mine's going to look different because I'm already logged in. So you'll have to create an account. It's only used for this. And then you just, oh, and it doesn't let me go on because it's not open yet. But if you email me, I'll send you a PDF of this so you can see the whole application. And in fact, I'll put that on our webpage so you don't have to email me, but you can if you want to. The other thing that I want to show you really quickly that I shared in the presentation, and I know that we have a minute left, so if you have to leave, I get it, is a folder that looks like this. These are our to learn activities. So we've built little kits. I'll just show you in Build to Learn. We have activities that are for ages 2 to 4 or 5 to 8. If you click on this, you'll see 3 activities and their materials. Now we are piloting giving out the kits themselves, but these would also be great things that you could purchase materials for with the grant. So if you needed some tangrams, we actually have these simpler ones that we could just send you the file for. But then we have these family tips, like how can I extend this activity a little more with my students? And there are 3 activities for each set of instructions. And then we've provided 4 steps on how to complete the task. And then the questions that, again, that you can use as an extension. Please, if you have questions, I know we're out of time, but let me go back to my first page here. This is my email address. Email me freely. Ooh, I love that they have tangram die cuts. Thank you so much, Jenny, for sharing that. Yeah, please let me know how I can help. If it's not something that I know, I will ask my colleagues. I'll get in touch with Chelsea, whatever we can do to support you, just let us know. And otherwise, thank you so much for coming and spending the time with us. I hope that you were able to get some ideas, and I appreciate your work. So with that, have a good day. Thank you all so much. We'll see you later.
Thank you, Kelly. And just to remind everyone, the sign-in is in the chat. You'll have to scroll up a little. There's also a survey to get an additional entry into the drawing for the prizes, which we're going to do in a few minutes. So if you fill that out, you will get an additional, your name in again. And that's also in the chat. And then we're just going to go back into room 1 where we had our breakout session. So it's room 1, or it's at the bottom of the agenda, where we're just going to kind of close up and do our giveaways. So thank you all for being here. And thank you, Kelly.